This is the Rogowski Coil Integrator Senior Project for Team 18 from Grand Valley State University, and our project is for RoMan manufacturing. A Rogowski Coil Integrator is for a Rogowski coil. A coil is a current transformer to measure alternating current. There is a large coil and a conductor. A large current is driven through the conductor and induces a magnetic field onto the coil, which then that current turns into the voltage in the coil, which goes to our Rogowski integrator.
The output of the Rogowski Coil integrator has to be a 0 to 5 amps RMS AC current that is highly proportional but scaled down compared to the input current. This means the phase variation has to be below 0.5 degrees, and the current accuracy error has to be below 0.5% for ambient temperatures between 0 and 60 degrees Celsius. Furthermore, the user must be able to select input current values between 0 and 20,000 amps with 500 amp intervals through user switches, and the power draw has to be kept below 40 watts at full load.
Displayed here is the function structure diagram of the Rogowski Coil integrator. As you can see, there are three inputs: power supply of 24 volts, the output voltage of the coil, and the user switch input. And then there is a single output of 0 to 5 RMS current.
Alright, this is an overview of the full schematic of our design. We have on the top left hot swap circuit, and then switches, and then on the bottom we have the power supply and step-down converters, and the switching amplifier. Then feeding into that is a buffer amplifier, and then going the final circuit is the voltage to current converter, all of which we'll go over in the slides.
This is the expected output of the integrator. It's RMS, so root mean squared. This is the top PCB board, which holds all the user switches. This is the bottom PCB, which includes the 50-60 Hz switch, the voltage to current integrator, all of the power supplies, including the hot swap, and the amplifier.
This is a simple schematic of the thermal management plan. The integrator is placed in a full enclosure for shielding purposes, so 26 watts of heat are dissipated from the BGTs to the thermal pad, to the aluminum block and housing, to the heat sink, and finally to the environment, using the conduction path as showed in the diagram.